Hello, my name is Mateo, and today I'm going to be doing a fatigue question from Chapter 8, number 23. Um, so I already have this question pre-solved because the first time I made this video it took me 21 minutes. So I'm going to explain it instead and go through each step. So in this question, it says to plot a log-log graph for an SN curve for bending, axial, and torsional for loading for a 1-inch diameter steel bar having an SU of 110 KSI, SY of 77, and a machine surface. And it wants you to do it. It wants you to find the fatigue strength corresponding to 10 to the 6 cycles or 6 to the 10, well, and 6 to the 10 to the 4 cycles. So the first thing to look at here is this equation, which is what we're going to be using to find the curves. We need to find the SN value. And so here we are given the SU, the SY, that it's a machine surface, and a steel bar. These two are very important, and I will get into why later on in this problem. So, for the solution, we have to make two assumptions before we start, because in the question we were not given this information, so we must assume that the steel bar is at room temperature, so CT is going to be equal to 1, and we're going to assume that CR is 50% reliability, because that was also not given, and yeah, we'll get into that a little bit more. And so here I did two charts, and I'm going to explain all this, but just to make it a little bit easier and more organized, it's all the same steps, so it's easier to put it all in a chart with the values here, and then the different types here, right? So the first thing we're going to look at is S10 to the 3, and we get this from looking at this table over here. So right down here we can see these three. So we have the bending, the axial, and torsional loads. So we can see that it's 0.9 SU and CT, 0.75 and 0.9 for the three of them. So we take those values and we come over to the table and we're going to write them down. So 0.9, right, SU, CT. So this is our first equation to find S10 to the 3. And so if we do 0.9 times 110, because 110 was what we were given in the question, right? And then times 1, because that's what the temperature is. And we get 99 KSI. For the next one, we get 82.5 KSI. And then for the final one, we get 99 KSI. And so yeah, the next one we're going to look at is SN prime. So it's 0.5 times SU. The reason why it is 0.5 because that is because steel has the constant of 0.5. So we have to times it by our SU. So 110 times 0.5 is 55 KSI, and we have that for all three of them, right? Get rid of these. So now we're going to find everything else to solve this equation. So for CL, we can go back to this table. The loading factor right here. We can see that for bending it's 1, then we have 1 again, and 0.58. So we take those and we put them in the table here. So 1, 1, 0.58. So now we're going to look at the next one for the temperature, which in this table it would tell you, right? But we were not given a temperature, so that means we had to assume, and we assumed it was room temperature, so it was just 1. And that is what we write in the table here, 1, 1, 1 for all of them. So now for CG, come back to the table again. Gradient factor right here. So we can see that for bending it's 1, and for the next one it's 0.7 to 0.9. And so that value kind of ranges, and you just got to kind of pick of what you want. And I decided to go with 0.7 for this question. And for the final one, it's 1. So let's go back to the table and we write them all in. We got 1, 0.7, and 1 right here. So now for CR, which I explained above, we can look here. I said that for the reliability factor, we're going to go with 50% reliability, which is 1.0. And the reason why I went with 50% reliability, it's just what you want, it depends what you want, how reliable you want it to be. And I just decided to go with 50% and reliability. So I thought that was a good number to go with. So we write down that it's 1 for all of them right here. 1, 1, 1. And so now we have CS. So this one is a little bit more tricky to find. We can look at the table for the surface factor, and it's going to tell us that we got to use figure 8.13, which is the chart or graph above. And we can see here that we are looking at machine, the machine one, because it says machine surface in the question, right? And for the steel bar. So this is the curve we're going to use. And we were given an SU value of 110, right? So 110. So if we write 110 right here, and then we draw our line all the way up to here, where it intersects with this line, right? We can then draw across, and we have 0.74. That's also just an approximation. You really can't be that accurate with this. You kind of just need to take a guess. And that's how you find the surface factor value. So we can write that into the table for all of them, where we have 0.74, 0.74, 0.74. All three of those. So now that we have everything, we can find our SN value. So we're going to, for what we did here is we just plug them all into this, the equation that we started with. So first for Sn prime, we have 55 because we were given 55 right here, right? So we're going to plug 55 in. Well, we found 55, right? And then for the second one, it's going to be CL, which is 1. So we're basically just plugging everything in from this table here. So we have 1, 1, 1, and 0.74 for the surface value. And if you put that into your calculator, that is going to give you a value of 40.7 KSI. And then we do the same thing for the rest of them. 55 times 1 times 1 times 0.7 times 1 times 0.74, which then gives me a value of 28.5 KSI. Same thing for the last one, and we get 23.6 KSI by just plugging in all these values into the equation, right? So now, first part of the question pretty much done. We know our values, so now we just need to use the log-log scale. So with the log-log scale, we first have to write down all the different, like the values of the scale, right? So starting at 10 to the 3 to 10 to the 4, 5, 6, and 7. You don't need to go past 7 because it doesn't really go past that. And so then typically you would we'll start with bending, right? So this one, the bending, which we're looking at 10 to the 6, right? So we go up here, and well, we were given it's 40.7, right? So 40.7, if we look from here, right? And then we go over 40.7 is right here, right? And then you're going to look at your S10 to the 3 value, which is 99 KSI, which we're going to put right there. And then you would draw your line in, across, and over, right, when it intersects at the point. And that's how you do the first one. And for the second one, we do the same thing, 28.5. Where's 28.5? It's right here, right? Because if we look all the way across to here, it's 28.5. And then you draw your lines because we know that for the S 10 to the 3 value, it's 82.5. So that is right here. And then for our final one, it's going to be the torsion, which is right there for our S10 to the 3 value, We know that from here, which is 99 again, as like the first one. And then over here, we know that it is 23, so then we go up to 23. And then we draw the line in again. And then that's how we have our SN graph or lines. So the second part of the question, it wanted you to find the fatigue strength corresponding to the two cycles. So to make this a little bit organized again, I made a graph down here, and we're going to look at the first cycle, which is 10 to the 6, and wants to know what they line up with. So if we look at this pink line right here, we draw all the way up, right, until we hit, we go all the way up, right? And when we look at the, let me erase that, what it just did, so it's not too messy. And so that we see that when it intersects with the line, it's at 23, right? Because here it intersects with the line, and we go over, and it's approximately 23. The next one's 28 and 47. So they're pretty much the same values because that's what we were looking at anyways. So nothing too special about that. And they're in KSI. So now we're going to look at the next one where it's 6 10 to the 4. And this one's going to be different. So 6 10 to the 4 is about right here. And we draw, so if you look at the green line, it goes up, through, and it intersects with all the different lines in the graph. And we're going to do the same thing. So if we look at, for the first one, we'll do the torsion line, which is the blue line right here. And then if you go across, see where it lines up. And you kind of just need to guess because like it's hard to be accurate. And so I said that it was 48. And so if we look at the first one for bending, bending was the first line up here. So we draw the line up again, right? And right here, we go across. And where do we get? It's like right there. Yeah. And what was the value that I said it was? It was 80. And for the last one, it's the same thing. You go up, and it's this line right here, and you go across, and you see what the value is, and it's 51 KSI. So, hopefully that wasn't too fast. I was trying to make better time than the last recording. And yeah, I hope this video taught you something, and thank you for watching. Have a good day.